We're now going to walk through the implementation of the Handey Microservice. You'll see that this is fairly simple compared to the version that uses the Java or the Jakarta Persistence API, JPA, when we do the Zippy implementation. So we're going to start with the easy one first, and you'll see that this has the parallel and sequential reactor versions that we walked through briefly in a moment before. And as usual, you can get this code in the EX4 project, in the WebMVC folder, in my Live Lessons GitHub repository. So here we are in the repository, and we're going to start by taking a look at the Handey folder in the microservices package. Here's the Handey application, which, as you can see, extends the base application. It also has this component scan feature that says where to go to find the things it needs to do to connect the pieces together for component scanning. So as an example, one of the things you can see it depends on here is the server beans class. So let's go look at server beans. So server beans is annotated with a configuration. It knows where to go find the YAML file that is used to configure the Handey application. So here's the YAML file that we're dealing with. And this file is basically specifying the characteristics declaratively for the Handey and the Zippy microservices. And I added some documentation here today using ChatGPT to help me out, and it explains what the various fields and directives are here. So for example, the Handey application, which is the one we're using right now, listens on port 9100. It is going to be set up to have certain profiles enabled actively when it runs, and it gets the contents for its data set from this link. So it says where to find the data set. And if we go over here to the Handey folder, you can see, lo and behold, there is the list of Handey quotes. As you can see, I have separated them with the @ sign. You'll see why I do that in a second. That's just so I can do some clever regular expression parsing in order to snarf this thing in and turn it into a list. So that's where the data comes from for the list. This is the YAML file. The server beans, as you can see, knows how to access this YAML property source factory implementation, which is what actually parses the YAML file. This is probably something that will eventually be integrated directly into Spring, so you don't have to write this file or provide this file yourself. But this is the way I worked when I did it last year, and I haven't had a chance to see if they've updated that. Here's the bean that's going to be used to configure or auto-wire this field in the Handey service. So here's the list of quotes, the mQuotes field, and that's auto-wired to this bean, which is the factory that creates it. And you can see what it does is it opens up the file, which is the list of quotes that we looked at, reads that whole file into one big character sequence, and then it uses regular expression features in Java to split the file based on the @ sign. So you can see each string is separated by the @ sign. And then it goes ahead and takes the stream of strings minus the @ sign. It gets rid of anything that's empty, and then it turns each of those strings into a quote object. And you can see what it does is it gives each quote object, we'll look at the quote class in a second, it gives it a unique ID using a cool atomic integer feature, and then it strips off all the leading stuff from the quote and makes that be the string that goes into the quote. Here is quote. There's a lot of stuff going on in quote, most of which we don't care about for right now. We'll talk about this later. But quote is a Java class that has an ID, that's an integer, and a string that's the quote itself. There's a whole bunch of other annotations around here that we need when we use the persistent version of this. What we're doing here is not involving persistence, so I won't talk about that right now. So quote is basically a class that holds data, holds values. So you can see we have now a stream of quotes, and we turn that into a list of quotes, and that's what's going to get auto-wired into this quotes list. So that was a bit of a roundabout way of explaining some of the classes that are helpful in this application. Here's the Handey controller. Couldn't be more concise because the Handey controller just extends the base controller, and the various mappings that we have, like the get mapping and the post mappings, those are defined here in our base controller. And as you can see, the base controller is auto-wired to the base service, like the Handey service or the Zippy service. And all these methods just forward to the corresponding service method. So this allows us to factor out code so we don't have to repeat ourselves. So Handey controller, very concise. Finally, here is the Handey service. We talked about before, it implements the base service. The base service is just the one that is going to define an interface of the various methods that we need to implement in this service or the Zippy service. So get all quotes just returns the list of quotes that have been auto-wired. Get quote takes a quote ID and looks up in the list and returns the quote object that corresponds to that ID. Post quotes, which is what we looked at before, is the one that uses reactive programming with fluxes and parallel fluxes. And again, real quick, it turns the quote IDs list into a flux, which is a reactive type. We'll talk a lot more about that later. We make the flux a parallel flux. We then run the parallel flux either in a parallel thread pool or a single thread pool. It's kind of funny to have it be a parallel flux when it can run in a single thread pool, but that's just the way we get the semantics of this implementation. We then take each of the elements that are integers in the quote IDs, flux stream, go look them up in the quotes list, turn the whole thing back to a sequential, flux, collect the results to a list, execute a blocking call outside the current workers pool. We will go into that later. That's just something that we need to do to work with the reactive programming model. And then finally, we block until all asynchronous processing is done, and that will yield a list of quote objects. When we do web flux, you'll see that the nice part about it is we would just stop after collect list, and we would have a flux, and that would get turned back to the client, to the caller, which is much cooler. And then the last piece of the puzzle here is also super fun. This is the search method, and you can see here that there's actually a couple of different search methods. So the search method we have here takes a list of queries, and it's going to search in the list of quotes, for any of the quotes that contain one or more of the list of queries. So I'll explain that in a second. So we've got a bunch of different queries, and we're going to see when we look at the client side, we'll see what the queries are. They're going to be regular expressions, and these queries, I'm sorry, they're not regular expressions. They're just good old strings. And we're going to look up to see what might match in the list. So remember, this is the Handey quotes list. So we might look up something like bowling or grandpa. There's a bunch of funny quotes about grandpa. So we want to see if we find anything that matches. And we're going to either do this in parallel or we're going to do it sequentially. This gives us a chance to look at some really fun regular expression code. So here's a little helper method that I designed, and it's in the regex utils class called make any match regex. So what we do is we give it a list of queries, and we're going to return a regular expression string that will match anything that is in that list of queries. So let's go take a look at how that works. This is the method. What it's going to do is it's going to take this list of strings, which are the queries, and it's going to convert it into a regular expression of this form, where we say match things that are either lower or uppercase, and look for anything that matches the first query or the second query or the third query up to the nth query. So this is what's called an OR regular expression. So it's essentially a disjunctive query. And the way we're going to do this is we're going to turn the list of strings into a stream. We're then going to use the map operation to apply the pattern quote method. pattern is, of course, a Java class. The quote method in this class will return a string from the parameter here. And what it does is this string can be used to create a pattern that would match the string as if it were a literal pattern. So it basically will encode things in the string so they're not treated as regular expressions, because we don't want them to be treated as regular expressions. We just want to be able to OR these quotes, queries rather, that we're looking for into the stream. So now we have a stream of encoded queries. And the last thing we do is we collect them together using the joining collector. And what this does is it will stick an OR sign, this is the vertical bar, between each of these encoded queries. And then it will put this string here, the question mark I star open paren, which is this thing. It tacks that at the beginning of all these ORed together queries, and then it sticks this as the suffix at the end. So super cool, super interesting, and I was able to come up with this working with my good friend ChatGPT, which taught me some things about Java streams that I didn't even know because I hadn't bothered to read all the parts of the manual, whereas ChatGPT had read all the parts of the manual. So there's a video online that talks about how I did this. It's really cool. Okay, so that's how we make a list of strings into a regular expression. We then take that string and we essentially do the following. This is also pretty cool. So we're going to turn the list of quotes into a flux. We convert that to a parallel flux. We run that in either a parallel or a sequential scheduler. And then either in parallel or sequentially, we're then going to only keep the things that match. So this should only be the quotes whose quote field matches any of the queries. And so to do that, we're going to call this method called findAnyMatch. And this method, as you can see, is going to take the quote and the string of regular expression queries, and it's going to lowercase stuff so that we can do it in a canonical way. And then we're going to match. And so what it's going to do is it's going to say, does this quote here, which is the Handey quote, match anything in this regular expression string? And this matches method does regular expression matching. And by putting in this open paren, question mark, s, close paren prefix onto this regular expression, that tells the regular expression matching facility to enable the so-called .all flag that allows the matching of quotes across new lines. Now, just a little bit of side note. Who the heck wants to remember all this gobbledygook with regular expressions? I certainly don't. So once again, I used ChatGPT where I said, please take this code and convert it so it will match things across new line characters. And I gave it basically this prompt, and then it came back with that. So I could have spent hours looking up online trying to find examples of how to do regular expression matching across new lines. ChatGPT saved me an enormous amount of time. Once again, a nice way of being able to leverage generative AI to make your life easier as a programmer. So that's how we do the matches. Anything that matches goes through the filter, and then we turn it back into a sequential flux, collect the results into a list, and send them back. The last piece of the puzzle here is kind of interesting because what this does is this method will find anything that matches. It only returns a list of quotes that match all the queries. So the first one matched any of the queries, the one we looked up here. This matched any. And this one matches all. So once again, very similar approach. We call make all match regex. So this is a different regular expression. And what this does is it's going to take the list of queries, strings, and it's going to go ahead and use the map operation from Java Streams to transform each of these basically queries, which is a word. I probably should call this query, would be more sensible. map each query. And so it's going to create a stream of things encoded like this, which uses something called positive look-ahead pattern that matches the keyword or the query as a whole word. And then we create essentially a string, a regular expression, that joins all these things together. So we're going to end up with one string. And then down here, this is just so crazy regular expression gobbledygook. So we're going to put the wildcard pattern here that will match any string of any length that contains all of the keywords as whole words, regardless of the case. So once again, the incredibly complicated regular expression programming. Don't try to figure this out yourself. Use the tools, as I did. And now we end up with something that can match things as long as they contain all the keywords or all the queries as whole words. All right. So that is that. And then you can see over here, we take that regular expression and do pretty much the same thing we did before with using reactive programming. So that's a rather long-winded review of how this piece of code is implemented. Why does any of this matter? Because some of the stuff you'll be doing will leverage similar kinds of techniques using various parts of the next programming assignment.